Right. So that's the way you can do this problem fairly simply without even worrying. So, I mean, as you can see that some of the moments, right, just gives you more opportunity to mess up the math, which I think it just happened. If you forget to multiply, you multiply one of these by 9 instead of 18 or 27, just by accident, right? You could easily mess it up. But noticing that it's all symmetric helps you out a lot here. And symmetry is going to help us with the force in each member, right? So due to symmetry, let me make a note here. This is also symmetry, right? But due to symmetry, we only need to analyze half the structure. Because we've got 6 and 6 acting upward there. Let me write those in. This would be 6, what are we using? Kips? Yeah, kips. And this is also 6 kips. So let's start off with, I'm just going to arbitrarily take the left side because I already, I already worked it out that way. But, you could do this for either side. So I'm going to start with joint A. And I'm going to look at what that looks like geometrically. So I've got the point A over here. And what do I have? I have force AB, and I have a triangle that's, well, let me draw the other forces in first. I've got 6 kips here, and then I've got force AC. Right, so this is what my joint looks like at A. In terms of lengths, right, I've got 9 feet and 12 feet. And this will be 15 feet, right? So 3, 4, 5 triangle. So that's convenient. Now, it's easy to look at this and say, okay, I've got a Y force that I know. So let's start with the Y forces, right? This has no Y force. So now I've got sum of the forces in Y equals 0. So I've got 6. And the way I've drawn this, right, I've got plus FAB times the ratio 12 over 15. Right, and this gives me, well, let me write it down here. FAB equals negative 7.5 kips. So this negative tells me that this is directionally incorrect the way I've drawn it, right? So FAB is 7.5 kips, and that's in compression. So all I've done here is I drew it in tension, right? Pulling on point A. I did the math, I set this up, and I found out that, you know what, in order to make some of the forces equal 0 work, this has to be a negative 7.5 kips. So this actually has to be in the reverse direction. It has to be pushing on point A, which means the beam itself is in compression, right? Because it's like a spring being compressed. It wants to push back. So the beam itself is in compression of 7.5 thousand psi, 7.5 kips. Yeah, and then from here we just do sum of the forces in X equals 0. And now we have, all right, so we have FAC is positive. Now we know FAB is a negative, right? It's a negative direction now. We don't, I mean, you can do this and plug in the negative, but I like to just correct it as I go. Okay, I know that's pointing the other direction now. So, I mean, you can actually correct your diagram if you want to. So I've got FAB times the X component is 9/15, right? So here I basically have, I'll go over here. 0 equals, well, FAC equals, we've got FAB, which is 7.5 kips times 9/15. And this gives you 4.5 kips. So FAC is 4.5 kips, and that is in tension. And it's in tension because we drew it in tension. We treated it as if we, we're in tension, right? The way we drew it. We corrected our FAB, right? You got to make sure you correct the ones that you know. And we wound up with a positive value. So we're at 4.5 kips tension on A, or member AC. Next on here, let's see, we could move to B, which has 1, 2, 3, 4, or we can move to C, which has, we know AC, right? Point C, we've got 2 unknowns. Let's move to joint C. Now, joint C is interesting because it has an external force acting on it. So let's draw joint C. Let me draw our known forces. All right. So first of all, FAC is in tension. It's pulling on A, right? So if it's pulling on A, what is it doing to C? It's in tension. Remember AC.
Would be pulling on C as well.
It's pulling on C as well. Good job. Yes, the first way I phrased it, I was like, oh, that could be kind of tricky the way I said that. But yeah, that's why I spoke up again. So this we know is 4.5 kips. And that is in tension, right? So it's pulling on C. Let me draw in C here. All right, then we have 4 kips acting down. And let me draw the other ones we don't know yet, right? We've got CE. And what is that, CB? So, I mean, just from the sum of the forces in X equals 0, right? We see that FCE minus 4.5 is 0. So FCE is 4.5 kips. And that is also under tension because we drew this pulling on C, right? And you can kind of intuitively see this, right, with this point, right? If this is in tension, pulling, right, this has to be pulling in the other direction because there's no other X component forces acting here. So this has to be the right direction. And that's how we treated it in tension, so it's in tension. So FEC or FCE, 4.5 kips, and that's in tension. And then we have some of the forces in Y equals 0. Here we have FCB is drawn as acting upwards, right? And 4 kips are down. So we can see here again, FCB is 4 kips, and that is also in tension. Because that's acting, we drew it pointing upward, right? We treated it as upward, and it came out positive, so it is upward. And again, intuitively, you can see this. That's kind of the nice thing about these type of points. It's like, well, you don't even have to worry about doing ratios or cosines or anything. It's like, oh, it's just straightforward. I mean, you could do this by inspection, right? But I'm writing this out so you can see, all the steps. So that's joint C. Which one did I do next? Oh yeah, I did do joint B next. Let me do joint B next. Joint B. So I'll probably have to go to the next sheet here. I'll start it up here. Problem 619. All right, just to be ready here for the. All right, let's look at the figure. What's happening with joint B? So joint B has got a bunch of different attachments. It's got 4 different, what do they call, members. Now, we already know, I'm going to do this. We already know what AB and CB are, right? AB and CB, we just calculated those. Now, AB is in compression. So if the member AB is being compressed like a spring, what is it doing to point B? Is it pulling or pushing on point B? Yes, no? No one's going to answer. It's pushing on point B. So just like it's pushing on point A, and I didn't draw it down here, obviously, because this is the drawing I drew initially. So joint B is going to have, let me draw it with red here. This is force AB, and this is 7.5 kips. I'm going to start using K for kips here. And then we have, BC or CB. Now, CB is in tension, right? So let's go up here. CB is in tension. Is it going to be pulling or pushing on B?
Pulling.
I thought I heard someone say pulling. So yes, it's pulling on B. Oh, I should draw. Let me label this. This is B. Let me draw CB here. I should have used the other. Well, this is actually heading in that direction. So force BC is 4 kips, right? So force BC is the equal and opposite of force CB, right? And then we have 2 other unknown forces. So we have FBD, and I'm going to draw these in tension, right? So again, this eliminates the need of having to look and guess and think, all right, now, let me draw these out and then I'll talk more. You guys like talk less. This is FBE. All right. And remember, we have dimensions in here, which I don't even know what color. I'll use pencil. Let's see. The dimensions are, remember, this is 12 feet. And this is 9 feet. And these are like 15 feet. Right? All right. So I drew these in tension. Now you can kind of see, well, if you're pushing up like this, you're probably going to have some force pushing back somehow. But you may not necessarily know which one that is. Now, let's start. What do you think is going to be easier to start with? Well, I guess it doesn't really matter here, because both of these, this has an X component, this has an X component and a Y component. Yeah, you know, it's probably easier to start with some of the forces in the Y, because then you only have this unknown, right? Some of the forces in Y does not include this force. So I'm going to start with some of the forces in the Y equals 0. And again, I'll define Y as positive vertically. So what do I have? I have 0 equals, I'm going to have, I'll start with the easy one, right? Minus 4K here, right? Then I've got the vertical component of FAB, which is, let's see, 12/15. So I've got plus 12/15 of FAB. And then I've got minus 12/15 of FBE. So remember, let me put the number in. FAB, that's 7.5 kips. So let's see, did I even do the math? Looks like I just jumped to the solution. FBE, well, I did the math on a calculator, is 2.5 kips. So this is solving for FBE, right? Notice I would add these two together. I probably should have done an intermediate step. 7.5 times 12 divided by 15. Yeah, I get 6 for this, plus a -4. I get a 2. I bring it to the other side. I've got the signs cancel, right? So 2 times 15 divided by 12 gives me the 2.5 kips. So this is under, oops, this came out positive, and we drew it in tension. So, oops, we drew this in tension, FBE, right? So it is in tension. All right, I'm gonna have to move. Next page. All right, so now that I have FBE, I have all the known X components except for one, right? Joint B continued. Some of the forces in X equals 0. All right, so now we're going to write all the forces we have in the X direction. BC is all Y component, right? So we've just got the X components of these plus FBD. So I'll write FBD first. And notice I'm going to the right is positive, right? So FBD is positive the way I've got it drawn. Then I've got FAB acting positive. The X component is going to be 9/15. And then FBE is also acting positive. So I've also got a 9/15 of FBE. Maybe I should plug the numbers in for this one. Hold on. Let's see. 9 times. What do we got here? Here we've got FBD is the heck. Oh, why did I put FBD? This is FAB. Oh, Jesus. I lost track of what pen I'm using. This is FAB. 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 This is a fab tension. All right. No wonder I couldn't find the number. 7.5 kilonewtons. And FBE we said was 2.5, right? So here we wind up with 0 equals FBD. This is really FBD. Plus, let's see, 7.5 times 9 divided by 15 is 4.5 plus, I've got 2.5 divided by 5, basically. Plus, is that right? Hold on. I have a mistake somewhere. 7.5, 2.5, 9/15. No, I don't have a mistake. I think I made a calculator error. No, I didn't. All right, so I'm just not with it today. Oh, there it is. Yeah, I did make an error. 1.5. All right, so now I can see that when I solve this, FBD equals negative 6 kips, right? So I drew FBD in tension. What does this mean? What is FBD? Is FBD is in tension or compression? Anyone? FBD is in compression, right? Because I drew it in tension. When I solved the system of equations where I set it up in tension, I found out that it was the wrong direction. So it's actually in compression. So 6 kips in compression is FBD. All right, notice we've only have one more joint left. Oh wait, we've got, I didn't do E. Oh, yeah, it's just the members. Yeah. All right, so notice here that you got to sometimes go through this and check these off. I've got AB, I've got AC, I've got CE, I've got CB, I have BD, and I have BE. The only one I'm missing, oh, I'm checking these off and I'm now on the only one I'm missing is DE, because all these other ones are symmetric, right? AB and FH are the same. Well, but they're identical forces, right? AC and GH are under the same forces, right? Because everything's symmetric. So I've got to now solve for DE. Now, I mean, you could try to do joint E if you wanted to. It's just a lot more math. The easiest place is point D. So I'm going to go to joint D. And what does joint D look like? Joint D looks like this. It's got, that's the joint. We already know FBD. Which we just calculated. That's 6 kips. Oh, I forgot to quiz you guys. Yeah, FBD is in compression, right? The member itself is in compression, so it's pushing on the joint. Then we have DE down here. And over here on this side, we've got, this is FD. Now, we already said we have symmetry, right? You can clearly see, well, there's a few ways you can clearly see this. You can either know from symmetry that FFD is equal to FBD, or you can look at this and say, okay, sum of the x's is 0. This is pushing on D to the right. This has to be pushing on D to the left for the same equal and opposite force, 6 kips, right? So this is in compression as well. And this is equal to 6 kips. This is either by symmetry, which is kind of the point of this problem, or sum of the forces in X equals 0, right? And then obviously for joint D, we've got sum of the forces in Y equals 0. Here we've got a negative FDE, and then that's it, right? So FDE is a 0 force member. FDE equals 0 kips. So now if you were writing these all out for each member, let me see what I'm going to do here. Oh, I know, we'll move it up. So member DF is equal to member BD, which we've already solved for, and that's 6 kips, and that's in compression. All right, this is now the symmetry part of it. I'm just listing out all the rest of the joints. We've got HF is equal to AB. And what do we find? AB was 7.5 kips. And that was in compression. We can do AC and, well, HG. So I'm just writing the other side here, right? This is the right side. Right. Left. HG is equal to AC. And AC was what? AC was 4.5 kips. And that was in tension. Let's see, GE. GE is analogous to CE, which we found the member CE was also 4.5 kips. And that was in tension. Then we've got FE. Well, yeah, we can do them either way. We'll do FE equal to BE, right? And that was BE, 2.5 kips in tension. And then we have FG is analogous to BC. And what was that? That was 4 kips in tension. And then, of course, DE, right, is by itself. And that's a 0 force member. So yeah, that's how you do one of these problems. So you can see if it weren't for symmetry, this could take quite some time, right? If we had unbalanced forces, we'd have to go through and analyze. I mean, we did 1, 2, 3, 4 joints, right? We would have had to go through and do another, well, 3 of them at least. So yeah, so that's method of joints, but you can see how time consuming that can be. And you can see for a problem like this, I think there's one in your homework in symmetry, or that's symmetric. You know, the symmetry really helps you. You solve a lot less equations, and you get the answer quicker. So it helps you in a few things, right? It helps you with both the free body diagram and the I mean, you know, some of the moments versus some of the forces in the free body diagram isn't that big of a deal. But you can see by some of your answers, there were some calculation mistakes. It's very easy, I found, with some of the moments to, if you're trying to go through it real quick, you know, accidentally look, you know, I've done it myself. And I'd be like, how the hell did I get that wrong? And it's just because I forgot to multiply. I look at the numbers here and I say, instead of 3, I use 2, right? So instead of multiplying by 27, I use 18. Wow, this took us the rest of the class period. All right, so next time we're going to discuss method of sections, which is actually fairly straightforward. But now that you know all this, method of joints, you can definitely start your homework. And yeah, and you'll be prepared for method of sections on Wednesday, because method of sections is very similar to method of joints. It's just it just allows you to find the forces in members without having to do them all. So I think you'll appreciate that.